Hello and welcome to video 2.0. I can prove angle pair relationships, theorems, and their converses. Before we begin this lesson, I just want to give you guys a quick warning. This is going to be a longer lesson and there's going to be a lot of proof involved. So I need you guys to bear with me and don't try to do this in like the 10 minutes between classes. It's not going to work. But let's take a look. The first thing we're going to prove is the alternate interior angles theorem. And the alternate interior angles theorem states, if two lines in a transversal form alternate or congruent alternate interior angles, then the two lines are parallel. So the basic way we do proofs, our given statement is always going to deal with the hypothesis of our if-then statement. Two lines in a transversal form congruent alternate interior angles. So what I'm going to do is I'm going to choose a pair of alternate interior angles. I'm going to choose 3 and 6 because I like them, no other reason than that. And my given is going to be that they're congruent. Angle 3 is congruent to angle 6. And then what I'm trying to prove is always my conclusion. The two lines are parallel. So I'm trying to prove that K is parallel to L. Now, in order to do this, I always want to find a helper angle. And my helper angle always needs to have a corresponding relationship with one of my angles and then an easy either vertical angles or linear pair or something like that relationship with the other one. I see 8 is a really good helper angle because it corresponds with angle 3 and it's vertical to angle 6. I could have chosen 2. 2 would have also been a good helper angle because it corresponds with angle 6 and is vertical to angle 3. But I'm going to stick with 8. So let's take a look. We always have statement and reason on our table. And my first statement is always what I'm given. So in this case, that's that angle 3 is congruent to angle 6. That is given. And guys, notice how I'm lining up my statements and my reasons so that they're easy to read and pull together really quickly. I'm even numbering them so I can tell. Then I'm going to use that vertical angle theorem to state that angle 8 is congruent to angle 6 by the vertical angle theorem. Right? And it's okay to shorten things. Vertical angle theorem. Well, now I know that 3 is congruent to 6 and 8 is congruent to 6. So I can say, because they're both congruent to 6, angle 3 is congruent to angle 8 by the transitive property of congruence, transitive POC. Well, because I've now stated that two angles that are actually corresponding angles are congruent, remember we have a theorem that says, or a postulate that says, if corresponding angles are congruent, then my lines are parallel. So I'm now able to say that K is parallel to L because of my corresponding angle postulate. Okay, because that postulate states that if two corresponding angles are congruent, then their lines are parallel. All right, let's go ahead and look at 2. Now we're going to do the converse of the alternate interior angles theorem. So we just proved how to take a pair of congruent angles and prove lines to be parallel. Now we're going to go backwards. We're going to start with two parallel lines and we're going to prove that their angles are congruent. So this is the reverse of the previous statement. So if two parallel lines are cut by a transversal, remember my given is always in my if statement, in the hypothesis. So my two parallel lines are K parallel to L, and I want to prove that alternate interior angles are congruent. So I'm going to prove the same set again, just so we can see the similarities. I'm going to prove that angle 3 and angle 6 are congruent. Angle 3 is congruent to angle 6. And just like last time, I'm going to choose angle 8 to be a helper angle for me because I need helper angles in order to prove this effectively. So we always start off with our given, K parallel to L, And don't forget to write statement and reason on your table. K parallel to L because it's given to me in the problem. Now, I'm going to look at my relationship with the helper angle and those other two angles. Well, my helper angle and angle 3 have to be congruent. Angle 3 is congruent to angle 8 because we know that corresponding angles are congruent if lines are parallel. So that's the converse of the corresponding angles postulate. Okay, it's the converse because we're starting with our parallel lines and then saying angles are congruent. Well, I can also see that my helper angle and angle 6, angles 8 and 6, they're congruent. Angle 8 is congruent to angle 6 because they're vertical angles. My vertical angle theorem allows me to say that. And finally, if 3 is congruent to 8 and 8 is congruent to 6, well, we can then conclude that angle 3 is congruent to angle 6 by the transitive property of congruence. All right, guys, let's take a look at this next one. Given K parallel to L and the measure of angle 1 equals 25 degrees, prove that the measure of angle 7 is 25. Well, let's start off by setting up our table and writing down our givens. All right, well, let's take a look at this problem. They tell me that 1 is 25 degrees, that's 25 degrees, and that K is parallel to L, and I want to prove that 7 is 25 degrees. So I'm working on this angle right here. Now remember, we always want a helper angle, one that's corresponding to the angle I'm given, and it has some kind of easy relationship with the other one. I like angle 5. I like angle 5 because it corresponds with angle 1, and it's vertical to 7. So it's got a nice easy relationship with 7, and it corresponds to angle 1. So it's going to help me out. So because of that, I'm able to start off by saying that angle 1 and angle 5 are congruent by the converse of the corresponding angles postulate because they're corresponding. Well, so we've got that they're congruent, but remember, when we're dealing with congruency and equality, we have to constantly switch between signs. So if I say that 1 is congruent to 5, I can also say that 1 equals by the definition of congruent. And this is important because I can't substitute measure of angle 1 equals 25 into a statement with a congruent symbol. So now in this next step, I'm now able to make that substitution step, and rather it's not really a substitution step as it is a transitive step, because if I say that the measure of 1 equals 25 and the measure of angle 1 equals 5, measure of angle 5, then I can say that 25 equals the measure of angle 5. So that's more of a transitive step. And now we're going to look at the other pair of angles, our helper angle, angle 5, and the angle we're interested in, angle 7. We're going to say how they're related. Well, they're vertical angles, and we know that vertical angles are all congruent. And they're all congruent by the vertical angle theorem, so that's my reason there. But remember, we can't mix equality and congruency, so I'm going to have to go through now and do another step to show that angle 5 and 7 are in fact. And we can always say that things that are congruent are equal by the definition of congruence. Well, my very last step is going to be another substitution step. I got that 25 is equal to the measure of angle 5, and by the way, guys, that is supposed to be an equality symbol. Pins give me trouble, equals. So this next step, I can substitute in now and say that that 25 is equal to the measure of angle 7 by the transitive property of equality. But the problem is I don't want to end with 25 equal to 7. I want to end with 7 equal to 25. So my very last step is to say that the measure of angle 7 is equal to 25 degrees by the symmetric property of equality. So now so that proves what I wanted to prove. Now let's look at our next one. In this proof, we're going to want to look at the consecutive interior angles theorem, the converse of the consecutive exterior angles theorem. And we start off with if two lines are parallel. So my given are my parallel lines, K parallel to L. Then consecutive interior angles are supplementary. So now I want to choose a pair of consecutive interior angles, and just for kicks, I'm going to choose 3 and 5. And to show that they're supplementary, that's my proof statement. Angle 3 is supplementary to angle 5. And as always, before we start a proof, we always want to choose a helper angle. And my helper angle needs to be corresponding to one of those angles in either a linear pair or vertical to the other. I'm going to choose angle 1 because it's a linear pair with 3, but it's corresponding to 5. That's a good helper angle. Angle 8 would have also been a pretty good helper angle. I'm just not going to use it. And angle 8 would have been good because it corresponds with 3 and it's a linear pair with 5. But it really doesn't matter which of those two you choose. And we begin always by setting up our table with our statement and reason and our givens. I think I'm going to start off by talking about the relationship between helper angle 1 and angle 3. Well, we stated at the very beginning that they were a linear pair, and so I need to include that information in my proof. We're able to say that by the definition of linear pair. Well, we also know that all linear pairs are supplementary by the definition, and so we also need to include that information in our table. I can use these quote marks to show that it's the same reason as before, and I do one for each word. Well, we also know that if two things are supplementary, then they add to 180. And it's really important to include that they're supplementary and that they add to 180 because really the only way we're going to be able to get eventually that 3 and 5 are supplementary is if we're able to eventually get them to add to be 180. So that kind of sets up the relationship between angles 1 and 3. Now we need to do a section that relates angles 5 and 1. So remember, we're thinking about the relationship with the helper angle. Well, I know that 5 and 1 are congruent because they're corresponding. So we have to write that congruency statement in our table, and the reason is the converse of the corresponding angles postulate, because I'm given the parallel and I'm proving the angles are congruent. Now, because we've got this statement up here where we're using addition and an equal sign, we need to make a step to convert this congruent symbol to an equal sign. So that's my next. And anytime we make that kind of conversion, it's always the definition of congruent. Now remember, our goal is to prove that 3 is supplementary to 5. Well, looking at this, I have 3 plus 1 equals 180, and 1 equals 5. And so what I'm able to do here is where I've got measure of angle 1 equals, measure of angle 1, I can substitute in for that measure of angle 5. So that's going to be my next step. Degrees by and we really like that step because it's a good substitution step, and now we're completely set up to finish this. I need to actually end with the statement angle 3 is supplementary to angle 5, which I'm now able to do because the definition of supplementary is that they add to 180. Well, we've got that in step 7. So my reason for step 8 is definition of supplementary. And we're done with the proof. Now, there's going to be a second video. I need you all now to pause or to get to the end of this video and pull up the second one. I will not count this homework complete unless if you watch the whole of the second video. Thank you very much.